Hello friends, welcome to my channel again. In today's session we are going to talk about Lamport's clock. This is very nice and important concept in the distributed systems. Lamport's clock provides a way to order the events in the distributed system. It also ensures that the system remains in the consistent phase, and it also takes care that the causal relationship between the events will be preserved. So in short, we can say that Lamport's clock helps in ordering the events using logical clock. So ordering of the events is taken care by the Lamport's clock. Whenever the new event occurs on a node, the associated timestamp is increased. So for ordering the event, a timestamp is assigned to every event and it is increased, and with the help of that, or we can define the ordering of the events using the Lamport's clock. Lamport's clock is a fundamental concept in distributed system and it has numerous applications. It can be used in distributed databases. It can be used in distributed file systems. Lamport's clock can be used in distributed transactions and in consensus protocols. So Lamport's clock has lots of applications. Lamport's clock is also known as Lamport timestamp. It is a mechanism for ordering the events in the distributed environment. The primary purpose of Lamport's clock is to provide a way to determine the causal order of events in the system where multiple nodes or processes are involved. Communication between the nodes is asynchronous. Clocks on different nodes may not be perfectly synchronized. Let's go into the detail. We will see the happens before relationship in the Lamport's clock. Happens before relationship is defined as follows. If an event A occurs before event B in the same process, then A happens before B. So this is what the happens before relationship, and it is denoted by the arrow. So A event happens before B. Its timestamp is less than the timestamp of event B. If you observe the diagram, this is what the timeline. The time is increasing in the upward direction. Event A is happening before event B on the timeline. So we can say that event A occurs before event B. It is represented that A happens before B. And this arrow shows the happens before relationship. Lamport's clock has various types of events. Local events can be there, external events can be there, message sent event can be there, message received event can be there. So let us take information about what these events are. In Lamport's clock, no two events can have same timestamp. When one node sends message to another node, it includes its current timestamp with it. Now refer the given diagram. There are two nodes, node 1 and node 2. So multiple events will get generated on these nodes. This is what the timeline that is shown, and both these nodes are using Lamport's clock on them. Now P1 and P2 are the local events for node 1. Similarly, Q1, Q2, Q3 are the local events for node 2. Local events are the events whose execution is done locally, and these events do not depend on the events running on the other nodes for their execution. So these are the local events. Lamport's clock orders the event with the help of timestamp. Now let us say that P1 event is having timestamp equal to 1. P2 event is getting executed after P1 event. Timestamp of P2 event is 2. Similarly, for Q1 event we can say that timestamp is 1. For Q2 event which is occurring after Q1 event, then timestamp is supposed to, and Q3 event is taking place after Q2 event, so we will say that the timestamp of Q3 is 3. So arbitrarily the timestamps of local events are increased by the node on which they are getting executed. So here we have increased the timestamps of local events by 1. Let us consider Q4 is the event which is sending message to the event which is running on node 1. We will call it as P3 event. Timestamp of Q4 is 4, which is more than the timestamp of Q3. So Q3 is happening before Q4. We can write the relationship between Q3 and Q4 like that. Q3 is happening before Q4. Timestamp of Q4 is more than that of Q3. Q4 is sending a message to P3 event. P3 event is happening after Q4 as well as after P2 on this timeline. So we will say that the timestamp associated with P3 is 5, which is more than the timestamp of P2 as well as which is more than the timestamp of Q4. Now one more event is there, P4. This P4 event is sending some message to node 2 and Q5 event is getting executed. So timestamp of Q5 should be more than that of P4, the timestamp of P3 was 5. So we will consider that the event P4 which is happening after P3 event, we will consider the timestamp is equal to 6. P4 event is sending message to Q5 event, so timestamp of Q5 should be more than timestamp of P4, so we will consider the timestamp equal to 7. So in this way the timestamps are assigned to the events which are getting executed on different nodes. So if you see the events are ordered, we can say that P4 happens before Q4, we can say that Q4 happens before P. So this is the happens before relationship. We know that there are 4 types of events in the Lamport clock: local event, external event, message sent event and message received event. Now we will see the conditions for executing local events. For a new local event, timestamp is increased arbitrarily. For example, local timestamp equal to local timestamp plus some arbitrary value. Here we will consider the value is 1. So if there are 2 events, P1 event is there and P2 event is there, we will say that these P1 and P2 events are local events for node 1. Similarly, Q1, Q2 and Q3 events are local events for node 2. So if we want to calculate the local events timestamp, so we can say that, for example, for local event P2, the timestamp will be calculated as P1's timestamp plus the arbitrary value that we are going to add into P1's timestamp. Here we have added the arbitrary value as 1. So here P1's timestamp is 1 and P2's timestamp is 2. So similarly, here we said local timestamp of P2 can be local timestamp of P1 plus some arbitrary value. Here we have added the arbitrary value, or we consider the arbitrary value as 1. If P1 happens before P2, then we can say that timestamp of P1 will be less than timestamp of P2. Now one important statement that we need to remember: a sent message event is also called as local event and its timestamp is also incremented in the similar way. If we observe the earlier diagram, here Q4 is a sent message event and it is considered as local event. So the earlier event was Q3. I have added 1 into that and I have calculated the timestamp for Q4. So in this way the timestamp of the local event message sent is calculated. In this diagram, Q4 is a sent message event which is treated as a local event. Similarly, P4 is also a sent message event which will be also treated as a local event. So timestamps of P4 and Q4 event will be calculated exactly in the same way in which the timestamp of local events are calculated, because these are the message sent event and message sent events are considered as local events. Now let us talk about the conditions for executing external events or received messages. For received message event, timestamp is calculated as timestamp is equal to maximum of local timestamp comma received timestamp plus 1. Let us see the diagram. If we consider this event P3, so local timestamp is 2 on node 2. So local timestamp of P2 is 2, which is given here. Now P3 event is a received message event. P3 is getting a message from Q4. So let us consider the timestamp of Q4 also. So based on this timestamp and this timestamp, now we are going to calculate the timestamp for P3. So P3's timestamp, so timestamp of P3 is calculated as a local timestamp which was 2 for P2 event as we have discussed here, and received timestamp. So we will see what is the received timestamp. So received timestamp is 4, which is shown here. So let us put the value. Received timestamp is 4. Let us find out the maximum value out of these two. So it will be max of 2 comma 4. So obviously the value will be 4. We are going to add 1 into that. So total value will be 5. So 5 will be the timestamp of the event P3. So which is written over here. If you see the diagram, so that time also we have considered the timestamp of P3 as 5. So this is how we calculate the timestamps for the external events. So it is very important to remember this formula while calculating the timestamp of external event. So that's it from this video. So thank you for watching the session carefully. I feel that you might have enjoyed the session. If you are having any doubts, please put them into comments. I will try my best to reply your questions. Please share this content with your friends who are learning distributed systems algorithms. Also like the video and subscribe to my channel.